In computing, a database is an organized collection of data or a type of data store based on the use of a database management system, DBMS, the software that interacts with end users, applications, and the database itself to capture and analyze the data. Hardware database accelerators, connected to one or more servers via a high-speed channel, are also used in large volume transaction processing environments. DBMSs are found at the heart of most database applications. DBMSs may be built around a custom multitasking kernel with built-in networking support, but modern DBMSs typically rely on a standard operating system to provide these functions. Databases are used to support internal operations of organizations and to underpin online interactions with customers and suppliers. See enterprise software. Databases are used to hold administrative information and more specialized data, such as engineering data or economic models. Examples include computerized library systems, flight reservation systems, computerized parts inventory systems, and many content management systems that store websites as collections of web pages in a database. Database languages are special-purpose languages, which allow one or more of the following tasks, sometimes distinguished as sublanguages: data control language, DCL, controls access to data. Data definition language, DDL, defines data types such as creating, altering, or dropping tables and the relationships among them. SQL became a standard of the American National Standards Institute, ANSI, in 1986, and of the International Organization for Standardization, ISO, in 1987. Database access control deals with controlling who, a person or a certain computer program, are allowed to access what information in the database. The information may comprise specific database objects, for example, record types, specific records, data structures, certain computations over certain objects, for example, query types, or specific queries, or using specific access paths to the former, for example, using specific indexes or other data structures to access information. Database access controls are set by special authorized, by the database owner, personnel that uses dedicated protected security DBMS interfaces. This may be managed directly on an individual basis, or by the assignment of individuals and privileges to groups, or, in the most elaborate models, through the assignment of individuals and groups to roles which are then granted entitlements. Data security prevents unauthorized users from viewing or updating the database. Using passwords, users are allowed access to the entire database or subsets of it called subschemas. For example, an employee database can contain all the data about an individual employee, but one group of users may be authorized to view only payroll data, while others are allowed access to only work history and medical data. If the DBMS provides a way to interactively enter and update the database, as well as interrogate it, this capability allows for managing personal databases. Data security in general deals with protecting specific chunks of data, both physically, i.e., from corruption, or destruction, or removal, for example, see physical security, or the interpretation of them, or parts of them to meaningful information, for example, by looking at the strings of bits that they comprise, concluding specific valid credit card numbers, for example, see data encryption. Change and access logging records: who accessed which attributes, what was changed, and when it was changed. Logging services allow for a forensic database audit later by keeping a record of access occurrences and changes. Sometimes application-level code is used to record changes rather than leaving this in the database. Therefore, organizations must take database security seriously because of the many benefits it provides. Organizations will be safeguarded from security breaches and hacking activities like firewall intrusion, virus spread, and ransomware. This helps in protecting the company's essential information, which cannot be shared with outsiders at any cost. Types of database: relational databases. A relational database's contents are arranged as a collection of tables with rows and columns. Accessing structured data is made most flexible and efficient by relational database technology. Object-oriented databases, Similar to object-oriented programming, data in an object-oriented database is represented as objects. Distributed databases. A distributed database is made up of two or more files that are spread across multiple locations. The database could be dispersed across many networks, housed in one physical place, or kept on several computers. Data warehouses. A data warehouse is a sort of database created especially for quick query and analysis. It is a central repository for data. NoSQL databases. Unlike relational databases, which specify how all data input must be formatted, NoSQL, or non-relational databases, permit the storing and manipulation of unstructured and semi-structured data. The prevalence and complexity of online applications led to the rise in popularity of NoSQL databases. Graph databases. Data is stored in a graph database using entities and their relationships. OLTP database. An OLTP database is a quick, analytical database made to handle lots of transactions from several users at once. Cloud databases. A collection of organized or unorganized data that is housed on a private, public, or hybrid cloud computing platform is known as a cloud database. Cloud database models come in two flavors: traditional and database as a service, DBAS. With DBAS, a service provider handles maintenance and administrative duties. Databases play a critical role in managing and organizing data efficiently in today's data-driven world. Understanding the types, structures, and purposes of databases is essential for anyone working with data, whether in tech, business, or any other field. As technology continues to evolve, so too will the capabilities and importance of databases, making them a foundational element in the digital age.